അറ്റൻഡൻസ് ചാറ്റ് ബോക്സിലിട്ടെ ഞാൻ വീണ്ടും എടുക്കുക, ഇടയ്ക്കൊന്നും കൂടി എടുക്കും. ചാറ്റ് ബോക്സിൽ ഇപ്പോഴൊക്കെ. So next we want to discuss 0/1 knapsack problem. യൂണിവേഴ്സിറ്റി എക്സാമിന് ചോദിച്ചിരിക്കുന്നത് 6th മോഡ്യൂളിൽ നിന്ന് ക്വസ്റ്റ്യൻ വന്നിരിക്കുന്ന ഡിഫൈൻ 0/1 knapsack problem and how can solve, write a program or algorithm to solve 0/1 using backtracking. അപ്പോൾ ഇങ്ങനെ ഒരു ക്വസ്റ്റ്യൻ ആണ് ഈ ഒരു സെക്ഷനിൽ വന്നിരിക്കുന്നത്. ഓക്കെ, അപ്പോൾ എക്സാമിന് വന്നിരിക്കുന്ന 2 ക്വസ്റ്റ്യൻസ് ആണ്. ഒന്ന് 0/1 knapsack പ്രോബ്ലം എന്ന് പറഞ്ഞ് ഡിഫൈൻ ചെയ്യാം. രണ്ടാമത്തത് ഹൗ റൈറ്റ് എ ബാക്ക് ട്രാക്കിംഗ് അൽഗോരിതം ഓർ പ്രോഗ്രാം ടു സോൾവ് 0/1 knapsack പ്രോബ്ലം. അപ്പോൾ അതിൻ്റെ ഫസ്റ്റ് നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത് വാട്ട് ഈസ് 0/1 knapsack പ്രോബ്ലം. Okay, so what is 0/1 knapsack problem? We already discussed what is knapsack problem. So given n positive weights wi, then there are n objects, n positive weight wi, and then positive profit pi, and a positive number m, such that m, that is the knapsack capacity. What is the problem? The problem is finding a subset of weights such that these two conditions should be satisfied. One, wi into xi should be less than or equal to m, and 1 less than or equal to I less than or equal to n. Okay, and we want to maximize this profit function. Okay, P into xi is maximized. That is, we want to fill the knapsack with some objects, satisfy that in such a way that should satisfy these two. Okay, so this is the objective function to be maximized. This is the constraint. This is the constraint, and this is the objective function to be maximized. And xi can take value 0 or 1. Okay, so either I can include the object fully into the knapsack, or I can't do that. Okay, so here that is the difference between fractional and 0/1. Either I can include or not. Okay, so this is xi will take value 0 or 1. Okay, so next we want to discuss the algorithm, because this is somewhat complicated. Its working is very complicated. Okay, its working is, that is, creating the state space graph. In the previous case we discussed this Enkin problem and how can create a state space graph. Okay, based on this algorithm, and this is complex, but we can understand that. But the problem here is this is very complex process. Okay, so anyway, we will try to familiarize with the algorithm. Okay, so the algorithm is a university exam question, so please study this topic. Okay, so first we want to familiarize the algorithm. Okay, first we want to familiarize the algorithm. Okay, so this is also a recursive algorithm, BNAP. Okay, BNAP is the main algorithm, and it takes the 3 parameters K, CP, CW. Okay, so first I am discussing the structure of the algorithm. Okay, then there are 3 parameters K, CP, CW. Then in the first part we will try to create a generate left child. Okay, in the first part we will try to create a left child. Okay, then if this condition is satisfied, that is, if current weight Cw plus W of K less than or equal to M, then we will generate the left child. Okay, if this condition is satisfied, we will generate the left child. Okay, so that is one topic. So this is the code for doing, this is the body of that. Okay, this is the body. And next, if that condition is not satisfied, what we will do? If that condition is not satisfied, then the next is we will do this one. Okay, you can note here. Here there is another if. Okay, this one. This is equivalent to generating the right child. Okay, this is equivalent to generating the right child, and in that we will call the bound function. We will call the bound function, and if the bound function is satisfied, then we will try to generate the right child. Okay, so this is the code for generating the right child. This is the code for generating the right child, and there is another algorithm is the bound, which is the bound function, and this is another algorithm. Okay, algorithm bound. Okay, so you should study all this algorithm thoroughly. Okay, so this is about the structure of the algorithm. Basically, this is the main algorithm we map, and there are three parameters. Then first we will try to check, is it possible to create a left child? If it is satisfied, I can. So then I will execute this code. Else I will check if bound. If this is satisfied, I will try to generate the right child. I will try to generate the right child. Okay, right child. This is the code in that. We can discuss that later. Then what is bound function in this problem also defined here. This is the bound function. Okay, okay. This is the structure of this algorithm of solving 0/1 knapsack problem using backtracking. It's a very lengthy algorithm. So okay, next we are familiarizing the various terminologies. Okay, so in this algorithm, usually you should observe this one. Bmap, this is the main algorithm name, and K is the one parameter. Okay, CP is another parameter. CP means current profit. Okay, CW is another parameter, current weight. Okay, so these are the three parameters to the B knapsack problem. Okay, B knapsack algorithm, and it is a recursive algorithm. Okay, it is a recursive algorithm because it is using backtracking. It is a recursive algorithm, so the function call itself until we'll get a solution or not. Okay, so another parameters are K. K is the object taken. There are n objects in an there will be n objects, then it will take any of the value K. K will take 1 to n values. Then CP. What is CP? CP is the current profit. Okay, CP. The term CP means current profit. What is CW? Current weight. Sorry, it is W. This is not weight. This is weight. Okay, weight of the object. This is current weight, and M is the capacity of the knapsack. Then W of K means weight of the kth object. Okay, so there will be n objects like this. Okay, so there will be n objects like this is 1, 2, 3, 4, and there is weight and P. Okay, for each object there is a weight. Okay, we already studied fractional knapsack using dynamic programming approach. Okay, so here discussing using backtrack. So What is W of K means weight of the kth object. P of K means profit of the kth object. Okay, what is P of K? For each object, a profit is attached. For each object, a profit is attached. It's already given. Okay, so then another terminology is Y of K. Okay, in this algorithm, we will use a one-dimensional array Y, and it is used to store the intermediate result of processing. Okay, we will use a one-dimensional array Y of K. Then X of K. X of K means it's a one-dimensional array to store the final solution. Okay, so there are two one-dimensional array we are using. Okay, Y and X. Okay, so next is FP. What is FP means? Final profit. Okay, FP is final profit. It is basically initialized to -1 or 0. In our text, I think it is -1. Sometimes it will be 0. There will be no problem. Okay, so it will be -1 or 0. FP is the final profit. After you will get the final profit value in this variable. Then another is bound function. Already I told you what is bound function. There are three parameters: CP, CW, K. CP means current profit, CW means current weight, K means the object, kth object index. Okay. So what is the use of bounding function? It is used to find the best solution. Okay. So this is the bounding function. So this is the algorithm for bound function. It will take a 3 parameter and it will do some process and it will return the B value. B. B means how much the solution is best. It is an indication of how much the solution is suitable. Okay. So that is B. So so this is about the parameters used in this algorithm. This is about the parameter. So first we discussed the structure of the algorithm. Then we discussed important parameter. It is a recursive algorithm. Now what we are trying to do is that we are trying to analyze the working of this algorithm. As I told it, it's a huge algorithm, it's a large algorithm, and its workings is somewhat complicated. Okay, so we are trying to analyze how this algorithm will work. Okay, how this algorithm will work. Okay, so then only we can, at least we can discuss this algorithm. Okay, so now in this class we are trying to analyze how it will work. Okay, so this is the problem and this is the problem. Okay, so there is n objects. There are 4 objects. Okay, n is equal to 4 and a knapsack of size 16 is given. Okay, knapsack of or a bag of size 16 is given. Okay, and okay, knapsack of size 16 is given and object profit weight is already given. Okay, so x1 object, its profit 40, its weight 20, x2 object 35, x3 50, 10, x4 10, 5. Okay, so if needed we can calculate this term PA by WA. Okay, so this will be given in the question. Okay, so solve the 0 bar 1 knapsack problem using backtracking approach. So we want to familiarize how this algorithm will work. Okay, so initially what we will do is that, okay, please observe, this is you should need a good idea about how a recursion will work. Okay, so initially we will call the knapsack with the values 1. What is 1? We will take object 1. Okay, this is 1 and profit is 0. Current profit is 0. Current weight is 0. Okay, we will start with the object 1. We will start with the object 1. Then That is, this knapsack algorithm is called with these values. Okay. Then what the knapsack algorithm will do? This you can, this is a state. Okay. We will reach at the first state. That is, this is basically the body of the knapsack. Okay. This is the body. The blue color I am showing, this is actually what the knapsack algorithm will do. Okay. I called knapsack with these values 1, 0, 0. Then I started executing knapsack. That is actually the state. Okay. So what it will do? Okay. What it will do? It will, you can note here, I'm just going to the algorithm. Okay, as I told, okay, so this is called with 1, 0, 0. Then it will try to generate the left child. Okay, it will try to generate the left child. So if you want to generate the left child, this condition should be satisfied. CW plus W of k less than or equal to M. Okay, this is the condition to be satisfied to generate the left child. So uh, what will happen? This condition is checked at first. Okay, this condition is checked. You can note here what it is doing. So you can note here M is the capacity. Okay, M is the capacity 60. Then the current weight is, initial weight is 0. Okay, so please observe what we are doing is that here in this state, what we will do is that this is the current weight. Okay, this is the current weight. Okay, then 0 plus, okay, in a state, what we will do is that current weight plus 2. What is 2? We are now, this is object 1. Okay, we are trying to add the object 1. Okay, object 1. What is the weight of the object? What is the weight of the object? This is 2. Okay, 2. Okay, so we will add the current weight with the object weight. Okay, 0 plus 2. Okay, current weight plus the object weight. That is this term plus weight of the object. Object 1. So 0 plus 2. And we will check whether it is less than the M. Yes. So this condition is satisfied. Okay, this condition is satisfied. Then what we will do? We will try to generate the left child. Okay, we will try to generate the left child. Okay, so that is, here this condition is satisfied. Okay, okay, in this case this condition is satisfied. So what we will do? We will first set y of k is equal to 1 in that state. Okay, in that state we will try to set y of k is equal to 1. Okay, so there is an array y and here we will set 1. Okay, this is basically a solution vector, temporary solution vector array. Okay, in that we will set this is 1. Okay, then what we will do? Okay, then we will check this condition. Okay, check this condition. If k less than n, so what is k now? 1. 1 less than 4? Yes. So we will execute this. That is, we will call the function again with these parameters. Okay, we will call the function again with this parameter. Observe here what we are doing. We will call, okay, we will call the same function with the current weight. Okay. Okay, this is very important. The last one is current weight. Okay, current weight, CW. Okay. If you observe, so the current weight is one parameter, which is 2. Okay, then what is current profit? Okay, just observe that. So this term, forty is current profit. What is the current profit now? So current profit is, you can observe what is this parameter, middle parameter. Okay. P of k. So that is the middle parameter. So this is, okay, please note here. P of k. P of k. Cp plus P of k. Okay. Cp plus P of k and profit of 1. K is 1 now. Okay. So P of 1. Okay. P of 1. So it will be equal to 1. So P of k. 0 plus P of 1. What is P of 1? Profit of the first of it, which is 40. Okay. So then we want to repeat that process. Okay. So in a state, what I am doing is that first I will check current function again with these parameters. Okay. I call the function bnap with 2 comma 40 comma 2. Okay, 2 comma 40 comma 2. Okay. Calling this function again. That is recursion. It's a recursive one. So what will happen? The same process repeats. Okay. So you can note here. I reached that. So what I will do from this state? Okay. I reached at this state. Okay. I reached at this state. At first, what I will do? I will try to generate the left child. Is it possible? Okay, so 2 plus What is the weight of the object to 5? So what I will do next, I will check 2 less than 4. If this is satisfied, you cannot, I'm just discussing the working of the algorithm. Uh, okay, this is satisfied. The function again. Okay, this is the working. So what will happen? So make a note here. I will first set y. This I will set to 1. Okay. This is satisfied. So next I will set this one. I will set y. Then I will check this condition. 2 less than 4? Yes. So it comes here. Okay, current weight is 7. Okay, so 2 plus 5 is 7. Will come here. So this is the current weight variable. It is 7. And what is the current profit now? Already it is 40. You can observe here. This is 40. Okay, this is 40 plus weight of the object 2. What is the weight of the object 2? It is 30. Weight of the object 2 is 30. So 40 plus 30 is 70. Okay, 40 plus 30 is 70. Okay. So that is, I will call the same function with the parameter 3 comma 70 comma 7. Okay, 3 comma 70 comma 7. Okay, so try to understand how this algorithm will work. Okay, so I will call the function again. So I reached this state. From here I reach at this state. So again I am executing the same code. Okay, so what is the process involved in it? Okay, so what I will do is that I will execute these steps. Okay, here what I will do, you can note here, this is the state. First I will check 7 plus 10. What is 7? So as I told, this value 7 plus 10. What is 10? This is 7. 7 is okay. Current weight plus what is 10? Weight of the third object. Okay, weight of the third object 10. So what is 10? I can go to here. Next 3. Weight of the third object is 10. Okay, so that is checked. 7 plus 10 less than or equal to 16. No, this is not satisfied. Okay, this is not satisfied. That means I will not generate the left child. I stop that. Okay, then what I will do, this is a very important, this is very important. That is, in this algorithm, this condition is failed. Okay, this condition is failed. Then what I will do, I will check, I will go to here. Okay, I will reach us here. This I will try to execute. That is, first I will check the bound. If this is satisfied, I will execute. Okay, first I will check this one, bound. I will call the bound function with the parameter. That is the first step. You cannot hear. You cannot hear. So there is a function. Okay, note this one. This is a function bound. We will call the bound function with the parameter 773. Okay, you can observe here, call with this parameter value. Okay, and call the bound function with this parameter value. So, what is bound function? So, what is bound function is, this is bound function. It will execute this part. Not explaining how it will execute. At last, I will return the value. This value I will return. I will return d value. So after executing it, you will get a value 80. Okay. After executing it, you will get a value 80. Then the bound function is called and it will return a value 80. Okay. So next what this will do? This will check this part. Okay. If bound greater than or equal to fp, already I told fp is initialized to -1 or 0. Okay. fp is basically initially assigned to -1 or 0. I am assuming here 0. Okay. 8 is greater than 0. So what I will do? I will 80 greater than 0. So I will again try to, we can go to the code, what we want to do next. Okay. I want to execute this code. Okay, I want to execute this code. So what I will do is that I will set y of k is equal to 0. Okay, I will set y of k is equal to 0, and you can observe here it is y of k is equal to 1. Okay, here y of k I want to set to 0. Y of k I want to set to 0. Okay, you can observe here. Here I am setting at this state. Okay, at this state I will set this to 0. Then what I will do next? So I reached until here. Then I will check k less than n. In this case, what is k? K is 3. Okay. In this case, in the state, okay, what is k now? K is 3. 3 less than 4? Yes. So what I will do? I will call the function again, bnap. So you can observe, if k less than n, then what I want to do? I will call bnap again with these parameters, k plus 1, cp, cw. Okay, but you can observe here, what is this parameter? K plus 1, cp plus p of k, cw plus p of w of k. But here, this is cp, cw. Okay, so you can, that is, I will call this function again with this parameter. Okay. Sorry, I will take one or two more minutes. Okay. Okay. So I will call the function again with these parameters. Okay. For 77, 77 and 4 object size is increased. So already I told you why it's 70. Just observe this bound function 77 4. Okay. Then I will reach at this state. Okay. I will reach. That is, again I am calling the knapsack algorithm. So I am starting from the knapsack. So what I will do? I will check. That is, again I am calling. That is, again I reached here. Okay. Again I reached here. Okay. Then what we will do? We will again execute this part. Okay. I think it's better to discuss. I think in the next class, or I will try to give it as a recorded video. What will happen next? Because it's a lengthy process and it will take time to consider. Okay. Okay. Thank you. We can discuss it in the next class. Okay. Okay. please give your attendance. Okay, starting from Akash Rajiv, and then you can leave. Okay, Akash Rajiv, Abhinandan, Abhinav, Advait, others. Advait, others, others absent ആണോ? അനുഗ്രഹ്, others absent ഇടുന്നില്ല. അതുൽ, അതിന് absent ആണോ? Okay. Devika, Dilna, Masna, Jasna, Sharon. So, Jasna. Okay. Next. The Sinha, Karthik, Kirtana. Okay. Sinha. Ijas. Napa. Neha. Okay. Nitin Babu. Pranav. Paisakar. Prasanna Nihala. Prasanna. Prasanna absent. Present. Present. Okay. റോഷൻ, റിസുന ആബ്സെൻ്റ് ഒക്കെ കുറേ ആയിട്ടുണ്ട്. റിസുൻ, റോഷൻ, സഹലാബി, സഹലായൻ. ഓക്കെ. സംഗീത്, സാരംഗ്, ഷാരുണ്, ശ്രദ്ധ. സംഗീത്, സാരംഗ്, സാരംഗ്. ഓക്കെ. ഷാരുണ്, ശ്രദ്ധ. ഓക്കെ. വൈഷ്ണവി, ബേബി സുഷമ, വിഷ്ണു വിനോദ്. വൈഷ്ണവി, ഓക്കെ. വിഷ്ണു വിനോദ്. ഓക്കെ. ബേബി സുഷമ, അഞ്ജിത, ഷെറോണ. ഓക്കെ. ഓക്കെ, താങ്ക് യു.